Now we are there. Well, welcome to everybody. That's the last session before lunch. So I'm the one who stands between you and lunch. I want to make it an entertaining session so that you get hungry. And it's all about Azure RemoteApp. And I did some benchmarking. My name is Benny Tritch, for those of you who don't know me. I'm an MVP, CTP, V-expert. And this session is going to be as two parts. One part is about what is Azure RemoteApp, and the other part is the benchmarking. Now, before I get started, all of you know about what RemoteApp is. Anybody in this room who doesn't know what a seamless application, no. Cindy, not you. Anybody in this room who doesn't know what a seamless application is? Microsoft calls that RAIL, Remote Applications Integrated Locally. So if you search for RemoteApp material on MSDN, also use RAIL as the search string. It's funny because internally they still use RAIL. Externally, RemoteApp, it's only a marketing term. Okay, so the other thing that you should notice is this is the Azure Platform. These are all the services. Well, it's like half a year ago. Those were the services that Microsoft provided through Azure. And we're going to talk about this. So just to give you an impression that Azure RemoteApp is only one little component inside the big universe of Microsoft Azure. As you can imagine, you can combine Azure RemoteApp to some of the other services that are there. And this is going to be the art of the future for all of you who are in consulting. So this is going to be your job of the future, combining the Lego blocks that are in here. So now I will introduce one of the Lego blocks to you. And the other thing is it really an attractive technology? Who of you already knows Azure RemoteApp? Okay, some of you have been testing, so that's like 1/3 to almost a half of the audience who says, okay, we've been playing around with that, that's great. The funny thing is, it was only introduced a couple of months ago. Microsoft officially introduced Azure RemoteApp in November 2014. So a bit more than half a year, and already when Ruben and Jeroen did their survey with VRC, Project VRC, and they asked, what is the desktop as a service offering that you want to use in the future? It was amazing that they did that in March, and at that time, Microsoft Azure RemoteApp already made it to the top ranks. The funny thing about it is, it says desktop as a service. The only thing that Azure RemoteApp does not provide is a desktop. It's all about the applications. There is no desktop, just to be very clear. But the definition of all that, how do we deliver access to remote applications, is typically referred to as desktop as a service. Application as a service is not an established term. So this is sort of confusing, but this is what it is. And now Azure RemoteApp, as the name indicates, is running RemoteApp on Azure and RDS on Azure. And there are some marketing messages like from people like Brad Anderson. Yeah, don't want to bother you with the marketing stuff. It's a service. Like I said, it uses the standard protocol, RDP, Remote FX. We have various clients of different platforms. I will show you some of the stuff later. It's easy scaling, in particular, without investing a lot of money. So that is the idea. And you don't need the broker, no web access, no gateway. All of the licenses are included. Everything it's an all-in package. And Microsoft wants you to put your legacy Windows applications on Azure. Maybe as an interim solution while you're working on new applications that are native cloud applications, for example, or web applications. So this is the general idea that Microsoft has. My personal theory is, and I learned that from Sean, because Sean made this announcement first, that he believes that it's only going to be cockroaches and Windows applications that survive if the world gets destroyed. And so I agree with him. So I believe that for a very long time we'll still have Windows applications because there are millions out there. And Azure RemoteApp is going to be the solution, one of the preferred solutions. Microsoft wants it to make the preferred solutions that ISVs put their legacy applications, their cockroach applications in the cloud. That is the idea. And more and more ISVs start asking, how can we do that? Okay, there are two deployment types originally, cloud and hybrid. I will walk you through the different concepts. As of today, Microsoft does not like this slide so much anymore because the pictures started blurring. Because at the beginning, the cloud deployment was what the name indicates. It was only meant to be on the cloud, only to live on the cloud, no connectivity to on-prem. On the hybrid deployment type was meant to be, hey, if I have some leading components on-prem, I want them to stay in the lead and only have my worker instances running in the cloud. But that had some implications that made things not so easy to manage, and so they started bringing stuff together. So today they do not refer to cloud and hybrid deployments anymore, but still there is some legacy from the early days, and this is why it's important to know how it works. Basically what Microsoft does, they're creating terminal servers on VMs that they host on Azure. Simple as that. Like you would do it, you create a VM on Azure, and then you install different roles and additional services and everything, and that creates the machines. They launch those machines from a template. So basically what they do is they build an OS template, and then they start it. So they're spinning up new VMs using that template. How can you do it? Well, when you create the template, the golden image, after you're done, you sysprep it. So what they have is they have a sysprep master image that lives on Azure, on storage, in Azure, and if you launch one of those VMs, they just spin up that VM and they customize it, and so it takes like 5 minutes or so, 5 to 10 minutes to spin up a new VM. And the VM includes the applications are published. And you have a persistent user data space of 500 gigs per user. You use this pre-built image template, like I said. And you build this image and you upload it to Azure. That is the idea. Then you have a client. Your client allows you to access those applications. You authenticate either using Microsoft ID or Azure Active Directory. Yeah, optional, you can do this DIR sync in order to connect your cloud deployment to your on-prem Active Directory. Pretty simple. Now, look at the hybrid deployment. Now, you still have the elastic runtime, you have a custom template image, and all of that is the same. But you also have an Azure VPN that connects you to your data center. So you can have all your data, all your databases, everything that you want to have on your on-prem. You can have on-prem and it's only connected through Azure VPN. You use your Active Directory as a must. DIR sync is not an option. You must use DIR sync because your Active Directory is in the lead. There is no Azure Active Directory involved in a hybrid deployment. So that is the difference. All of the rest stays the same. How do you create a custom image? So this is pretty much the step-by-step guide that you have to go through. So you see, you create a VHD, there are some requirements, so no connection broker installation, no encrypted file system, and so on and so forth. In the end, well, it's like a snapshot that you do, but this snapshot chain is not supported, so you cannot have versioning of your VM. So you need a very clean VHD. So in the end, you do a sysprep, and then you upload this VHD. I did that from my network, And I have some numbers here. So it took 14 hours, 25 minutes to upload the image because we're talking about an 8 gig full server OS image. And I have a DSL connection in my lab. It's 2.5 megabit upload. So it takes 14 hours, 25 minutes. And this is a PowerShell script that you simply start because what it does, it checks if your image is properly configured. It does all the plausibility checks, all of these requirements that I mentioned before, those are all checked. It goes through all that, and if everything is fine, it starts uploading the image. That's all. You do that from the Azure portal. It's like a wizard. The alternative is that you start creating this custom template in Azure. That's a new option that Microsoft added after we told them, hey, whenever we do one change in the master image, in the golden image, it's going to take us roughly 16 hours to upload. So like, okay, I've done one configuration error, and I have to upload an entire new image. And so it is not so easy to keep things updated. So this is why they decided, no, why don't we use a template that we already have on Azure and use that? And that's the idea that's behind that. But also, no rocket science. You just create the same kind of template image with a standard VM that you have in Azure. And in the end, you do also a sysprep, same mechanism. It goes faster. So like I said, you can connect to the on-premises resources either using VPN or using ExpressRoute. Those are the two options that you have to connect your Azure RemoteApp resources to your on-premises resources. Yeah, Azure Active Directory, 86 services, those are the things that you use for that. So you can activate that. For the benchmarking that I did not use a hybrid deployment. I used a cloud-only deployment. So I was also using Azure Active Directory, but not connected to any on-premises resources, because I wanted to have the raw performance that I can get from Azure.
Will it actually make a difference if you're just using DIRSync? So the authentication of the remote app will still happen with the...
This is correct.
Regarding
regarding the authentication, there is no difference because it uses federation, so all the necessary information and the hash codes and everything, the hash data, that is stored on Azure. So authentication is not a critical factor because we're talking, hey, does it take 1 second less or longer? This is not the critical factor. The critical factor is data. So if you connect back to data that lives in your own data center, how long does it take for the data to get loaded by the applications that run in Azure? So that is the critical factor. So this is what the client looks like. It is a separate client as of today. So it's not the same RDP client that you know and love. It's a different client. It uses RDP 8.1. It's available for all of these different platforms. There are some best practices. So before you close this client, please close all your applications, because closing this client will enforce all your applications to be closed. Now, if the applications do not store data automatically, well, data is lost. Simple as that. So make sure that you terminate all your applications before closing this thing here. Enable auto update and the redirection options like can I use local drives, can I use local clipboard, and so on and so forth. These are available through Azure RemoteApp, but you need to use PowerShell commandlets as of today. They're working on a new front end, on a new portal, and this portal will include all these features. Today, it's only possible to use that through, to activate and deactivate it through PowerShell. So there are today 2 service plans, how you can use that. One is basic, targeted at task workers, and the other is standard for the information worker. So here it's more like lightweight applications, and here it's more productivity applications. You see here maximum of 16 users per VM. And down here it's 10 users per VM. So is there load balancing included? No. It's a very simple algorithm that Microsoft uses. We spin up a VM, and then we allow users to log on to this VM. When this VM, like it's a basic plan VM, as soon as user number 16 logs on, he's going to be the last user who can use this particular VM. While he logs in, they're launching, spinning up a new VM, and user number 17 will go to VM number 2. So they're going to fill up VM number 2. You do the math, 32 users, and user number 33 will go to VM number 3. So there's no load balancing or resource balancing of any kind. It's a stupid algorithm, but it's an algorithm that just works. And it makes sure that Microsoft does not have to introduce any sophisticated load balancing logic into Azure.
So if connections are dropped, what are the options right now with this solution? Let's
Well,
say your DSL goes out, right? You had all your apps running.
Yeah.
How do you get back into VM number, let's say 2 that you were in, as user number 33, I don't know.
No, you have no
Or
control.
31, whatever.
You have no control.
So you won't be able to get them.
No.
This is it. Yeah, so you better get a pretty nice redundant connection.
Yeah.
Yeah.
So
Okay.
you have your connection to that machine. As good as your connection is to Azure,
So disconnect and
disconnect and
Yeah.
you disconnect it.
Yeah.
Yeah, from that particular machine. There's no failover, there's
Yeah.
nothing. It's, yeah.
getting back, no way.
Yeah, you get back.
You get back to
Yeah,
that.
yeah, yeah.
So it knows.
So, yeah.
There is a, okay.
Yes, you
Affinity,
get back, so
okay.
you reconnect, so all the reconnection functionality that's
Looks
built
okay.
into the protocol, because that's a protocol
Yeah.
feature. That works, it's no problem. So you can drop the connection and it reconnects, yeah. And it keeps the session for a while, but they're playing around with those settings. And
Okay.
probably in the future, we can configure it like we can today with our, with the standard RDSH installation through policies. Today, all these policies are pre-configured by Microsoft. How long is the session maintained after you disconnect and you want to reconnect? How long does it take until they really kill your user session and you create a new user session when you log back in?
Mhm.
There's a question? Yeah?
Okay. Will the data, like the other Azure products, be stored in on trees, spindles, etc.? So
Very good question. They don't disclose this kind of information. They store it on Azure.
and what happens?
It's basically OneDrive. It's like a OneDrive folder that they create for the users.
So we could assume that there is a form of redundancy if it's one, right?
Well, like it is for OneDrive.
If a user has his session, the application misbehaves, can the user kill his session?
Nope.
Who can kill the session?
You can kill it because when you log in as an administrator, you can give these machine an administrative account, and you sort of when you create the golden image. This is what I did. I created a local administrator, and this allows me to log back in and to start all the tools that I want to. So I can start Task Manager, and I can kill all the different.
You get a full session. Right?
Yeah, like you have, yeah.
It's also possible through the Azure portal. You can,
These are new features. These are the new features. Yes.
like you can do with works.
Yeah.
But really quick, on a practical level, so there is definitely pricing, they have tiered pricing, whatever. When you pretty much take this thing for a spin, are you using your MVP allocation for Azure, or you actually have to pay right now?
No, right now I'm using the MVP stuff.
Okay, so that's actually sufficient for...
Oh, absolutely, absolutely. I'll come to that.
Okay.
So here's one very important information. They always use an A3 VM, 4 cores, 7 gig of RAM for all of these VMs. So you do the math. You have 16 users, and they share 4 cores and 7 gig of RAM. Okay? So this is exactly what you get. And the price is really cheap, $10, $15. Now, what do you get for the $10? 40 hours are included per user. So the hourly rate, when you go over those 40 hours, is, well, 17.5 cents. But they capped the price at $17, which means even if your user runs the VM or his session 24/7 the entire month, it cannot get more expensive than the $17. As I said, all in, all licenses. So we're talking about RDSH, RDS CALs, we're talking about the OS license, everything is included.
Office, right, is part of it.
No, Office is not
365 is
included.
different.
That was at
That's a
the early
different thing.
stage. Office is not included. And the standard with the 10 users, max per VM, again, 40 hours, 20 cents, maximum is $23. You have to book a minimum of 20 users. Until now, they have a maximum of 500 users. If you want to have more, you need to call them. So they want to be careful. They don't want to have organizations with 10,000 users just starting using the service without them knowing. So you see, the price can go up to $17 and it stays there, which is very convenient. So it's 17 by 20, which is the maximum price that you pay if you have the standard plan in place for your 20 users. Unfortunately, you cannot buy 5 user packages so far, so we recommended that we want to have that kind of thing. So, now that you know what it's all about, how good is it? Is the performance good? And here, full disclosure, Microsoft contacted me in November and said, hey, you're doing all this nice benchmarking stuff, you have your methodology. Do you think you could do a project for us and test Azure RemoteApp for us? Because our test team does not exist anymore. The RDS team is now belongs to the big family. It's not like a product unit anymore. It's more like, hey, they are part of the Azure team and of the server OS team. So they don't have their own test team anymore. So their test team was merged with the overall test team. But the good thing for us is they have budget now because they don't have to pay for the test team members anymore, but they have some money to outsource testing. So they contacted me and said, hey, don't you want to do a project? And I said, are we talking about doing stuff for free? No, it's that we have money. Oh, it's like, good, now we're talking. And so in the end, they paid Ruben Strout, Chris Griffin, and me for doing those tests. The deal was that we do the testing with our methodology and we are not lying. We give them back the truth, like a white paper and videos without tuning anything. And it's up to them if they publish the information or not. They allowed us to publish that information that I have with me now for Ignite, because that was part of the deal. They invited Ruben and me to be as featured speakers to Ignite. They gave us a big room. They allowed us to get, they live streamed our session. So from that moment on, the news was out. So there was nothing they could do to prevent the news to be out. They checked our material before we presented it, but only they checked it for stuff that they had not officially announced, and they gave us access to do some testing. There are additional plans, for example, that I cannot mention here, so plans that go beyond the basic and the standard plan. And they gave us access to those plans to do benchmarking. For obvious reasons, they did not allow us to steal their thunder because they want to do the announcements, not us. So I have to keep my mouth shut about that, but I can share with you all the results that we collected for the plans that exist today. So our testing framework, we have an on-prem environment that reflects what we see on Azure, because we want to see how good are we if we build our own A3 VMs with our own servers in our lab. Then we have Azure RemoteApp, and we have a task worker scenario, an information worker scenario, and I will cover that in a moment. Like you see, here's the project team, and then we have the client component. We have a primary client, a client that we are looking at, while we are generating load from a secondary client. Sounds a little bit like Login VSI, and as a matter of fact, Microsoft asked us, hey, are you guys using Login VSI to run the tests? And we said, have you ever accomplished to measure the performance of published applications with Login VSI? And they said, no, we tried, but it didn't work. And I said, yeah, because the architecture doesn't support that, while our framework that we built, Sean Bass and Ruben Sprout and I, supports that kind of scenario. So we're using our own methodology. And so this is what's behind it. But some of the techniques used remind you of Login VSI. And we have those tracking components. So we're able to record all these videos. Everything that's going on the primary client is recorded in full HD at 60 frames per second. We're using frame grabbers, pretty much like the frame grabber that's over there in the other room, the Epiphone boxes. These are these little breakout boxes that allow you to feed in the video signal like I do in the projector, and it just records the video. It's screen recording, but happening on a device. Good. Like I said, we have secondary clients and we generate load, and we have one workload generator which is an auto IT script that is compiled. So it includes the entire runtime, and it runs for like 60 minutes, and it randomly starts a couple of individual applications. And then we have an information workload sequence, again 60 minutes. It starts multiple applications at the same time, generating more load. So these are the two secondary workloads that we have, and then we have primary workloads that go through all the necessary, all the important graphics formats that are supported on Azure RemoteApp. We don't have GPU support, so no OpenGL, no high-end DirectX, and so on and so forth. So this is why we have HTML5, we have JavaScript, Flash, QuickTime, WMV, some more simple DirectX work scenarios. So this is the methodology that stands behind it. Whoever has seen any of the sessions that Sean and I did in the past, well, basically this is it. So it's just a new version, a new variant of our benchmarking framework that we built over the last 5 years. Now we configured Azure RemoteApp, so for those of you who have already tested it, that looks familiar. So you see we have several Azure RemoteApp subscriptions that we're using. Well, the users, so you see I generated many users on Azure Active Directory, and those are the users that are connected or disconnected again. So at peak times I had up to 20 users running, and because you cannot, it doesn't make any sense to have more than 16 users, because as soon as you have user number 17, a new VM spins up. So it's not about finding out what happens if you have 200 users on the system, because the elastic runtime of Azure will be easily able to deal with that, because in an average, an Azure data center has 700,000 physical servers. So they don't really care about if we spin up a new VM or not. And this is the Azure RemoteApp management. The trick that we used was, like I said, we are using auto IT scripts to run each test, but we compiled those, and I used icons for the compilation process. So I was able to give each of our test applications an individual icon, and just by double clicking on this icon in the Azure RemoteApp client, we were able to start it. So that was the idea. While in the background, other sessions were running, generating load on the system. So this is what the Azure RemoteApp client looked like. You see all the published applications that we have for the individual tests, plus the workload basic, plus the workload knowledge worker. So when I start this one, it runs for 1 hour. Yeah, what I did is I introduced a dialog box that pops up for 10 seconds after each individual application run. So like every 2 or 3 minutes, there's a dialog box that allows me to interrupt the script because, well, troubleshooting was pretty hard if you have to wait 1 hour until the script is terminated. So this is something that I learned very early on in the project. And you see here, Perfmon, it's also a published application. Explorer, because I wanted to see what's going on. And we were measuring application launch times and dialog box response times and wrote this data, comma-separated files to the user, well, public user space where the documents are stored. That was the only place in Azure RemoteApp where all the users were able to write. Because when you think, hey, there's an image and now I'm a user and I can start Explorer, hey, I can start modifying the system. Nope, Microsoft prevents that. So you only have read access to many, many places, except for all users and the documents. So we were able to write all that data to that place. And I just started the Explorer and copied the raw data, and it allowed me to do the analysis about how long it took to launch applications and dialog box response times. Another funny thing was, depending on the plan we were using, it was either, in this case, it is an AMD Octeron, or it was an Intel Xeon. So there was not really a schema behind that. So sometimes you had an AMD CPU and sometimes you had an Intel CPU. So I asked them, hey, is there any logic behind that? No, we just take what we get from the other guys. It's just a VM. And I'm like, but there's a difference if I use one CPU or another from a performance perspective. No, there's no control over that. You can check it out. You have access to that easily, but you cannot control it. So the benchmarking results are, what we did is we went through many, many scenarios like, okay, what is if we install everything on Azure? What if we install it on-prem? What is the impact of the network? So what if we use LAN compared to the DSL connection that I had, which is 16 megabit down and 2.5 megabit up. So we also emulated this scenario in the lab. So I have a WAN emulator using a POSIT WAN emulator. It's not software, it's a hardware device. And so I was able to sort of reproduce exact conditions that I have when connecting to Azure. I knew that my latency to the closest data center was roughly 100 milliseconds. I connected to the Amsterdam data center. That was the closest data center from my lab. And the POSIT box allows me to monitor network traffic without using performance counters. Performance counters are always bad because what they do is they're using resources. On the other side, I was using Perfmon to see how many users are logged on. That is the brown line. What is the CPU load and what is the memory? Blue is memory, red is CPU, and brown is always the user. Or we were using like 2x2s, which compare two sessions. You see the same thing here with the performance monitor, but here recording the screen. So what you can do is you can see, when the performance, the perceived performance on the screen is like that, what happens on the Azure RemoteApp side in the infrastructure, the telemetry data. Microsoft was not able to provide us with the telemetry data directly, unfortunately. We were asking, and they asked us to send them our subscription number and the exact time, and they wanted to extract that from their huge database of telemetry data. We never received this data, so in the end we had to go through one dedicated session where we started Perfmon. So maximum for some of the scenarios we have 14 secondary users, one primary user, one Perfmon user, which in total makes 16 users to fill up the machine. Make sense? So these are the lessons that we learned. Good, let me show you what this stuff looks like, because I have like 5 minutes left. And these are the final slides. Now let's see the videos. So I have some videos for you, like Flash. And so it's a reference. Watch what runs here. You have the network over here, all in real time. And you have in real time the performance counter. So over here, we are running this automated script that simulates a user typing an address, and all that happens. It's not a lot of load that we generate. It's not anything that we do on the CPU side, but hey, now we have this flash thing, and you see, whoa, now we are using 10 megabits per second, and our CPU goes up massively. It's only one user.
But you're getting through frame grabber, right? A separate frame grabs?
Yes, a frame grabber on my controller machine.
But when you're running, actually, you don't see all of them side by side. Those are four separate screens, or you
It's
actually
full separate screens.
Okay.
It's full separate screens. I have multiple frame grabbers.
Okay. Okay.
So I was using some of my lab equipment, like the WAN emulators and the frame grabbers, multiple frame grabbers at the same time. And Camtasia and everything was there. So that was the first thing that we were able to see. Haha, we're massively using some of the resources. Okay, now we do a WMV redirection, and you see the CPU load. Let's do a fast forward. The CPU load is really, really low, while network is high.
So you're pumping to the client, pretty much.
Correct. It's client redirection.
Yeah.
So look at that. The mechanism works, and this is the effect that we see. On the Azure side, nothing. Because Azure just forwards the video to the client plays the video. Yeah, the network has to, well, to transport the video data in real time. So this is what's happening. And I mean, I'm playing that back
Oh, it's
from the
excellent.
cloud.
Excellent. Yeah.
Yeah, so it's really good performance. Now, let me go back to see what scenario it is. One primary user, one perf1 user, 8 secondary users on basic plan. So we will see some performance degradation. So if we move it forward, so now we have many users on the system, and you see it is not really nice anymore. And when I go back to the beginning, you see that it's really struggling with the color lookup table for a while. So like, oh, what kind of color do I need until the mapping really works? So you see that kind of artifacts, compression artifacts, when you put a lot of load on the system, because you see the CPU is really up there. There's not much headroom left for that particular application. And so you see the effects. Yeah, you start adding users, and you see the effect now with one primary user, one perf1 user, 14 secondary users, and we see also performance degradation under heavy CPU load. To see the CPU is almost all the time at 100%, and this has massive effects on that. So it's not a smooth thing that's happening. It's like every 2 seconds one picture. While we also don't have maximum bandwidth, because the other sessions are using a lot of that bandwidth. So that gives you an impression. Now, when we run 2 of those side by side, we can see effects. What happens if we are using, if we have heavy load already on the system, and if there's not so much load. You see the transition is much smoother here than it is here. So you see it directly side by side. What are the effects when you already have heavy load on the VM? So smooth transition on one side and very abrupt transition on the other side. So these were those things. And we have what we call a spectrum, where you run 4 different scenarios side by side. And I think this is one of the scenarios, yeah, where 14 users, where this here really falls behind, massively behind the others. because we have too much load on the system. But this is how we compare these things visually. Another thing that I have with me is a video that we recorded when we are ramping up users really, really fast. And that was interesting because you see here, I'm ramping up more and more users, and suddenly I get an error message. Oh, what's happening here? So these are the existing user sessions. But now I started digging into what does this error message mean? Well, this is very simple. That was a logon storm. The system waited until the next VM was spinning up, and it took roughly 7-8 minutes. And we told Microsoft this is not the kind of user experience that we want. Because if you have a logon storm in the morning, you want to be sure that your users do not get that crazy dialog box that tells them, oh, we ran out of resources, try later. Like, whoa, this is not very nice. So this is what we recorded and sent it to Microsoft because we said, hey, it took so long, 9 minutes and something, until this user was able to log on. Is this what you want? Is this kind of user experience that you want?
Hope not.
And the final thing that we did is, like I said, collecting the timing, like how long does it take to start applications, how long is the dialog box response time, all the different scenarios that we had. So this is the raw data, but then we brought it into charts, and the charts showed us some interesting stuff. Only if we put heavy load on the system, then the performance of starting applications or dialog response times go really up, but still in a range that are acceptable. We're talking about 3 seconds instead of half second. And there was another thing that we found out because somebody asked about the, you asked about the file server performance in the back end. And I'll tell you something, Azure beat my local machine. Whenever I have traditional spindles in a machine, the Azure SaaS backend beats me easily, only if I'm using a local SSD for me alone on bare metal. I come in close to the same performance. So the Azure file system is zooming fast, beating most of the local implementation. I was not able to reproduce that kind of performance in my own lab. They are faster. So that was amazing. That was one of the results. Okay, let's summarize stuff. We still have many missing features. I don't want to go through this because we are reporting them back and they're trying to work on all of those. No GPU support, single sign-on, multiple domains, and so on. So we found some limitations. But in the end, it is really cool stuff. It is a real good starting point. I tell you, probably it's not good enough for many companies today to host their applications. But you should start using it today because in half a year, they will be far enough that you can do that kind of stuff. And that will be a very attractive price model. And hey, you can just upload your standard Windows app to the cloud. Benedict.
Then you started with an introduction and said, well, you wanted to find out if the RDS team did a great job.
Yes.
What's your result on that?
Actually, they did a great job putting stuff together they knew. And we found out they have no idea what the customer requirements are. So the best way to help them, because they are more than willing to learn, is, and I started the client, go to the feedback. Because the feedback, let's see, the demo gods are with me and the network connection is there. Because here you have the feedback form and you see what they are working on. Give them your feedback because this is what they implement. They implement new features on a monthly basis and they ship them immediately. So when we started complaining and wrote the white paper and delivered all the results, because the results that we delivered, they look like these. So it was only a very small fraction of the videos that I showed you. This is the complete list of videos that we delivered to Microsoft. Behind all these links is a 4-up window. Like these test runs with the reference clock, or these 2x2s. Here are 2x2s, and up here are the spectrums. So this is the kind of information that we provided. And they found what the limitations are, and they're working like crazy, like, okay, log-on storms, we've never expected log-on storms. We were like, really? you have not expected log-on storms. And we suggested them what they can do in terms of how can you improve the management portal, like giving administrators the option, hey, I want to pre-launch 5 VMs, allowing me to compensate for log-on storms. And guess what? They implemented that kind of stuff. We already seen that in the previews. So they're really listening to us, so please give them that feedback. They are more than happy to learn from us because they have no clue. So yes, they are great guys, but they don't know our industry. They live in their ivory tower in Redmond, and they do the best they can do, and they need us as their scouts. That is the feedback. It's a great starting point, and I know Microsoft, they will learn. It will take them half year, 12 months, and they will be able to deliver a great service. Today, it's still a little bit rough around the edges. Okay, I will be out there. I need to finish. Thank you very much.